Hi, I'm Dr. James Button. Sorry that I can't be at the March meeting in person to deliver this talk, but I've been stranded in New York due to all of the weather that they're having. Sorry for any and all background noise. This is not a quiet city. So, this talk comes in three parts. Firstly, I'm going to tell you about the Decodoku games, and secondly, I'm going to tell you about how we use that to teach people something about the science behind it. And then finally, I'll tell you something about our new direction, which is making games for quantum computers. So the background of Decodoku is that quantum computers are basically something which takes a bunch of, well, any computer is something which takes a bunch of input bits and then interacts them in such a way that it gives the desired set of output bits. But they also need to remove the effects of noise. So the way that we do this in so-called surface codes is to put our bits, or in our case actually higher dimensional systems, we put them in a grid and we give them rules that they have to obey regarding their correlations with their neighbours. And then we can look to see if those rules are obeyed, and if they're not, then that is some trace that noise has happened, and we can use it to try and work out what happened. So with these clues, we have to try and work out what happened, but also how do we fix it given whatever experimental bounds that we have. So these are optimization problems. We have to work out the most likely set of errors which correspond to a given set of clues. So in our case, clues always cause groups of numbers that add up to a multiple of 10. And we can see here there's a 6 and a 4, here there's an 8 and a 2, and these ones add up to 20. So it's most likely that there was a group of errors around here, and one around there, and one around there. In some cases, we know good algorithms that can do this for more general and complicated cases, but in others, such as the one in our game, methods are very heuristic. So they're basically just a bunch of tips and tricks that we've come up with to slowly make our set of hints more manageable and roll it towards an eventual solution. But in these cases, the clues are numbers, and the quantum computer is a grid, so we have a grid-based number puzzle, and people that are not scientists do these things all the time. So we think that these codes are a good opportunity to let the public help us out in our research. So what we did is extracted the simple puzzle from all of the quantum stuff, distilled it into 3 games, one of which, Decodoku Puzzles, focuses on what happened. Decodoku Colors tells you what happened, and you've got to focus on how to fix it within the time constraints, because more errors keep happening, and you have to prioritize which ones you're going to fix. And then the combination of the two is our main game, Decodoku. So these allow the public to see the kind of problems that we research, and also let them help us out. So one of the primary goals of the project is allowing interested players a taste of being a scientist and following some sort of scientific method while solving these puzzles. And that's what you have to do to contribute to the project. We don't take data from the players on how they play. We require them to think about their methods, because we couldn't really get much from the data, so we need them to think about what they're doing and try and tell it to us. So it doesn't allow the public to contribute in such an accessible way as other projects in which they just create data naturally by playing, but that's not what we're aiming towards. It's one of the goals of our project to give people a taste of being a scientist if they want it. I originally imagined this might be done through Let's Plays, so this is basically a video of people playing a game, but people seem daunted by this. So on one hand, Let's Players seem uninterested in playing puzzle games. They want to play some sort of shooty game, or Breath of the Wild. Obviously, they want to play Breath of the Wild like everyone does. Other people don't really think of themselves as YouTube contributors. To put a video on YouTube, especially with their voice, is very off-putting for people. So the favourite method in the early days was for people to take a video of themselves playing the game and then post their method on the website Reddit. We have a subreddit, /r/Decodoku, where people can go and talk about our research. And that's also being used more generally for gamified quantum mechanics now. So if you want to go and post about your own stuff, your own games on Decodoku subreddit, then feel free. Based on this, we developed a new possibility, which was to generate a save file. This creates the same record of a game that you would get by just doing a screen recording of it, and can be commented on to explain the method. You typically open it in a spreadsheet, so of course it's not particularly fun. People don't think that spreadsheets are fun. There still is high threshold for full contribution. So we can also think about whether there's a better way to involve casual players while still making it clear that the full contribution requires a bit of effort. Our main focus is on people who want this full experience of being a scientist, and so will dedicate themselves a little bit to the boringness, but also we should think about how to involve casual gamers a little bit more. So the results we've got so far is we've got some good results, but we'd still love more, and especially we've got a new hard game in Decodoku, which sets a different and more advanced puzzle for the players to look at. For the results so far, our high scorer for Decodoku gets a score that's around 4 times my high score. He's got a great method which seems to use errors to try and correct itself. It's really nice to see. It's very interesting, and we're working with him to get a code version of this to really understand the algorithm enough that we can put it into a program, and then we'll work towards published work. We also have another player who was looking mostly at Decodoku puzzles and created a genetic algorithm for that, which has also been very inspiring for us. But we're also working with him on applying genetic algorithms to other problems. So the work so far has been successful in getting people who weren't involved in the science involved in the science. And you can see more about that at decodoku.com/results. So the second part of the talk is learning about the science. Basically, we had a series of blogspot posts which were intended as a course for the public, so they could work from the very basic details of error correction. So things like if you're talking on a noisy line, then you will repeat yourself. We take that principle and then generalize it until we get to the quantum error correction code that we use in the game. And we also have many more articles about quantum computation and specifically also anions. So, because this project comes from the field of topological quantum computation. I've already mentioned that we've got a community on Reddit, and we also had a Q&A session on Reddit with various researchers in Switzerland working on quantum technologies, which got many thousands of people looking at, and I think it was about 1,000 questions, so that was pretty great. I've also had the idea that we quantum gamification people should do an AMA on one of these Q&A sessions on Reddit. If anyone's interested in that, let me know. We've also got a YouTube channel where we have videos about our own games, but also other quantum games, and also an experiment using the IBM quantum experience. So finally, I'll tell you about games for quantum computers. So as well as games about quantum computers, as lots of people have made, I think we should also look at games for quantum computers. And to start this off, I made the first 2 games publicly available for quantum computers using IBM's publicly accessible quantum processor. So I've got one called Cat Box Scissors, which is just a variant of rock, paper, scissors, and Quantum Battleships is a variant of battleships. They're very basic. They're command line games using Project Q, which is a Python-based language for interfacing with quantum computers, but you can play them on an actual quantum computer. So the reasons why I think making games for quantum computers would be interesting is, well, I have multiple reasons, but the 2 big ones are that gamers, when playing games, find and harness imperfections. They find glitches and they use those glitches. If you look at people doing speed runs of games and they use glitches to solve, in 15 minutes they can do a game that takes most people like months. And this is by giving themselves godlike powers due to the glitches. And this will give us a new perspective on what near-term noisy devices can do, because they will inherently be glitchy, and we'll get this new perspective on what the glitches allow, what they can be used for, and what what the good and bad effects are. So that's explored in our game Cat Box Scissors. It's also a good way to get gamers and developers engaged. It shows that quantum computers are something that people can use, people can develop for. Give software developers something that they can start out trying to make on a quantum computer. At the moment, they probably think that that's completely beyond them, but it's something sort of trivial that they can try. And also, it provides a platform for educating people about quantum physics. And that's explored in our game Quantum Battleships, in which the battleships are basically Bell pairs, and by bombing them, you're doing a Bell test. You don't actually get told that in the game, but it's something that the game can be used for if people look at the background information. And we have more information on that in a Medium article, and I also made some articles on Medium about the two games themselves. So that's everything I want to tell you about the Decodoku project. Thank you for listening. And if I could hear you, I would answer your questions, but of course I can't. So you can comment them on the YouTube video and I'll answer them there. Thank you.